Everybody, and welcome to this video on forgetting theories. This is part of the cognitive psychology topic for Stage 1 psychology. Let's get started. So, there are many theories in psychology around why we forget information. Now, there's lots of variables that affect why we forget things, but there's also several theories which we've got listed here. So, we have the serial position effect, which is linked to the displacement theory. We have the interference theory, retrieval failure, decay theory, and consolidation theory. So I'm going to be discussing all of these and using relevant examples as we go. So starting with the serial position effect, which is closely linked to the displacement theory. So this uses the concept of the primacy and recency effect. So in other words, to put this simply, the displacement theory linked to the serial position effect looks at when the information is presented to us, and because of that, which parts of the information we're going to be more likely to remember. So there's two effects to this. There's the primacy effect, which suggests that we remember information near the beginning of a set due to our use of rehearsal to store it in the long-term memory. So in other words, if we're presented with a list of words, we're more likely to remember the first, let's say, 2 or 3, because we've got the time to then code them or store them into our long-term memory. Now, the recency effect means that we also remember information near the end of a set because of our short-term memory. So it's the most recent information, hence the term. So what this really theorizes is that we're more likely to remember information at the beginning and at the end and have less recall in the middle. So if we have a list of 10 words, for example, we're much more likely to remember the first 2 or 3 and then the last 2 and 3, but find difficulty remembering the ones in the middle. This is also real world applicable to when we remember the beginning and the end of a movie, or the beginning and end of a book, for example. So we tend to remember the first pieces of information and the last pieces of information more clearly than ones in the middle. So again, where it is positioned, hence the term. So this is closely linked to the displacement theory. So Murdoch in 1962 obtained very similar results to the graph I showed you previously. So he used recall of a list of words presented for 1 or 2 seconds, and he found that the probability of recall related to the position of the word in the list was very important. So in other words, its serial position. So it was hypothesized that when new information enters our short-term memory, the older information is replaced by the new. So this is what's meant by displacement. So the theory of displacement proposes that due to the limited capacity of the short-term memory, which we already know about, once this store is full, so once it exceeds 7, or give or take 2, new memories will replace the older memories. Now let's look at interference theory. So this suggests that retrieval may be impacted by similar information being confused with the memory. So there's 2 types of this. There's proactive interference and retroactive interference. So proactive interference occurs when previously learned information interferes with the new memories being created. A very common example is when you drive to the wrong workplace or to the wrong school because you worked there a year ago but no longer do. Retroactive interference is a little bit different. So this occurs when the new information being learnt interferes with what was already known. So an example of this might be learning a word in French, then later learning the German word for the same item, but then forgetting the French translation. Now, another theory of why we forget is retrieval failure. So this is said to occur when we don't receive the correct retrieval cues to access the memory pathway in the long-term memory store. So retrieval cues are stimuli in our environment that we present when the memory was formed. So this could be visual cues such as the face of a person in front of you. It could be other sensory cues, so a scent of perfume, what you were listening to at the time, etc. So have you ever walked into a room only to forget why you have come there or why you went in there in the first place? So often when you return to the location where the thought occurred to you, you'll be able to remember what it was. So another extension of this is looking at the Godden and Baddeley study. So they explored the impact of different contexts on recall. So in other words, where people were. So they asked scuba divers to learn a list of words on land or underwater. So they were then asked to recall the words in either of these contexts using a repeated measures experimental design. So all this means is that the same group of participants were used both for learning the words on land, and the same group of participants were used to remember words in water. So it was repeated, okay, with the same sample. So the participants showed better recall in the context for learning matched, when the learning matched the context. So for example, if they learnt the words underwater, they will recall better underwater than on land, for example. And the words learnt on land will recall better on land. So this suggests that context-dependent cues are important to recall, and without them, we may find ourselves searching for information we are sure we know. So this is also why it's recommended, if possible, you study in either the same room if possible or a very similar room to that you'll be taking your actual test, because studies have shown, like this one, that the context will depend on the cues and the retrieval process. Then we have the decay theory. So the decay theory states that without rehearsal or revisiting information, our memories will fade over time. In other words, they decay. So as far back as 1885, Ebbinghaus theorized that the brain's ability to recall information over time without rehearsal decayed on an exponential forgetting curve. All right, so his very famous forgetting curve. So this means that the loss of information is very rapid in the first few days, as you can see here, but slows to a slower rate or a lower rate over time, and continues asymptomatically, never fully fading, all right, but still going down nonetheless. Then we have consolidation theory. So this suggests that rather than decaying instantly, information in the long-term memory actually needs time to cement itself into stored information. So this means that if we don't give sufficient time for a memory to consolidate, it won't be remembered. So for example, this might be or involve you revising for a test just before going to sleep. So this supposedly gives your brain enough time to consolidate the information during the night and should be remembered well in the morning. So the theory came about due to cases of brain damage impacting newer memories, but not those formed earlier in life. So I hope you found this video useful. As always, if you've got any questions, let me know. Otherwise, happy revising.